Okay, now we're going to use Pythagorean theorem. Now it doesn't tell you to, it just says use identities to find the value of each expression. And be sure note what you have to find. So you might want to come down here and put cotangent theta equals and then maybe cosecant. But you are supposed to use Pythagorean theorem. Even if you say, but Mrs. Bow, on this one, it'll be just as easy to draw the triangles and figure it out that way. Yeah, but you may not. You need to use the identities. But we have some hints. We know that tangent's negative because it says tangent theta is less than 0. Well, tangent is negative or less than 0 in the second quadrant and in the fourth quadrant because look at, that's when the signs are opposite each other. Opposite over adjacent, so positive divide negative, negative divide positive. So we know that fact. We also are given the fact that cosine theta is negative. Well, cosine theta is negative in both the second and third quadrants. Well, look at where they agree. They agree in the second quadrant. Okay, so we have to find cotangent. Well, cotangent in the second quadrant is negative. But look at, in the first quadrant, cosecant, remember, sine and cosecant are positive. The y's are positive. So this answer is going to be positive. So right away, we know a lot about the answer just by some of the clues. But now we're going to use Pythagorean theorem. And because they gave us cosine, we will use this theorem, sine squared plus cosine squared, and that's on your note sheet, is equal to 1. Okay, so they give us cosine, and we have to find cosecant, and cosecant's the reciprocal of sine. So I want to get the sine squared by itself. So sine squared theta, we're going to subtract cosine squared from both sides. Once I do that, I'm going to put in the numbers. So 1 minus cosine is negative 3/5 squared. So sine squared theta is equal, I'm going to do the subtract first. Well, 3 squared is 9. 5 squared is 25. So instead of 1, I'm going to go ahead and write 25 over 25. So sine squared is equal to 16 over 25, but we want to find the reciprocal. We want to find secant. So cosecant, I mean. So cosecant squared is the reciprocal, 25 over 16. And now when we take the square root of each side, and we're going to take, remember there's a positive and negative version, we're going to take the positive version because cosecant's positive in the second quadrant. So cosecant theta, the positive square root of 25 is 5. The positive square root of 16 is 4. So cosecant theta is positive 5/4. Okay, so, and oh, look at what we know. We know, now, as long as you show me one of the Pythagorean theorems, that's enough. You don't have to show me both. We don't have to write cotangent squared plus 1 is equal to cosecant, but we could because we now know cosecant. Let's go ahead and do it that way. Cotangent squared theta plus 1 is equal to cosecant squared theta. Well, we want to get cotangent squared by itself, so now we're going to subtract 1, and cosecant is positive 5/4. We're going to subtract 1, so that is squared, subtract 1. So cotangent squared theta, well, 5 squared is 25, 4 squared is 16, so we're going to subtract 16 over 16. So cotangent squared theta is 9 over 16. So when we take the square root, we take the negative version. So cotangent theta, the negative version of 9 is negative 3, so negative 3/4. So if you didn't want to do the whole second version, I'm going to show you what you could do instead. As long as you show me one complete All right, so we now know that cosecant, so this is hypotenuse, and this is opposite. Well, cosine up here, cosine theta is negative 3 over 5. Well, that's the adjacent side. That's the opposite side. Whoops, opposite. Well, cotangent is adjacent over opposite. So negative 3/4. So for problems like this, you only have to do one of them in Pythagorean theorem, and the other one you can find by using the clues. Okay, we're going to do one more of these. Pythagorean theorem again. And now we need to find secant and cosecant. And we know cosine is positive. Well, we know cosine is positive in the first and fourth quadrants because the x's are positive in both those quadrants. So cosine is positive in those two quadrants. We also know sine is positive. That's positive 4/7. So sine we know is positive in the top two quadrants because the y values are positive only in the top two quadrants. All right? Well, where they overlap is that first quadrant. So in the first quadrant, all trig functions are positive. So when we say secant theta is equal, that will be positive, and cosecant theta, that will be positive. Well, we need to find cosecant. Cosecant's the reciprocal of sine. So right there, we can just do 7/4, and that's using the reciprocal identity. But we need to find secant, so we're going to use sine squared theta plus cosine squared theta. We could actually use the tangent, but because we don't know cosine, that would be difficult. So we'll use this one is equal to 1, and we know sine this time, so we need to get the cosine by itself. So it'll be 1 subtract sine squared theta. So let's put that in. So cosine squared theta is equal to 1 subtract, the sine is 4/7, and that's squared. So when we square the 4/7, that becomes 16/49. So we will write 1 as 49/49. And that's cosine squared theta. Let's see, 49 subtract 16 is 33. So 33/49. And now when we take, now we're not going to take the square root. We need to find secant, so we're going to do the reciprocal. So secant squared theta is 49/33 because it's the reciprocal. Now we're going to take the square root in here. Let me move it over here so we have a little bit more room. I'm going to change that to, there we go. Well, there we go. And then, oops. I'm not liking this very well. I stole that 4 from over here, so I'll put that back. Okay, so we're going to take the square root of both sides, and that will give us secant. And we know we're in the first quadrant, and everything's positive, so that'll be the positive version. So square root of 49 is 7. Well, square root of 33 is not a perfect square. So we have to multiply numerator and denominator by root 33. So 7 times root 33 is 7 root 33. And root 33 times root 33 is 33. So secant theta is positive 7 root 33 over 33. So that's 2 examples of using the Pythagorean theorem, at least for one of the pieces, finding two trig functions given two pieces of information where one of them are either positive or negative, and then one exact trig function. That's it.